So I wanted to break quickly here to catch everyone up on what the test is and how it was validated. Basically, Misha and Rob got a team together to analyze the genetics and epigenetics of people enrolled in the Framingham heart study. They created an ensemble AI and took a sample from the Framingham group who did not have heart disease and compared their DNA and DNA methylation patterns with a sample of people who did have heart disease. That gave them an understanding of what things were likely to be different between those groups, genetically and epigenetically. The AI was tuned so that it would be able to predict, based on who had heart disease and who did not, who was likely to develop heart disease in the next 3 years. This is called the development cohort because that's the group of people that was used to develop the AI. Next, they took what they had learned and looked at another sample of different people from the Framingham enrollees who did not have heart disease and got the AI to predict who would develop heart disease within 3 years. They then looked at what happened to those people over the next 3 years, whether or not they developed symptomatic heart disease, and judged how accurate the AI was. This is called internal validation because it is still internal to the same cohort of people, the Framingham enrollees, as was used to develop the AI itself. They found that the AI in this case was very, very accurate, much, much better than traditional methods like the American Heart Association calculator, which uses cholesterol levels, high blood pressure, and other factors to estimate a patient's risk. But they figured that people who enrolled in the Framingham study might have certain things in common that were unknown unknowns. What they needed was external validation, testing a completely unrelated group of people outside of the Framingham participants. So, as they discuss, they met the people with Intermountain and they took their own AI without any changes and used it to make predictions on an entirely different, separate group, the Intermountain Inspire cohort. They did the same thing as they had done previously with the Framingham group, analyzing a group of people who were known to not have heart disease, and then had the AI make predictions and followed which people ended up developing heart disease over the following 3 years. Once again, the AI outperformed the regular risk factor-based calculators. In fact, they tested whether you could get extra accuracy from combining their AI with the regular calculators, and it turned out that the calculators added nothing or made the predictions worse when compared to using the AI alone. Again, this is interesting because the AI did not take into account the lipids or blood pressure or smoking status, only the DNA and DNA methylation patterns that were seen on the blood sample. So many test makers would stop here, but we still wouldn't really know if we were just finding an accidental association. One way to start looking at whether these were false associations would be to test whether a change in the patient would affect a change in the test results. We know that smoking is a huge risk factor for developing heart disease, but if we could get patients to stop smoking, would we see a change in the DNA methylation and their risk for heart disease as expressed on the test? They tested that idea, and it turns out that you can see a change. This is crucial, as we discussed later on in the podcast.